Okay, so today we're going to start looking at some 3D truss problems. So first we have problem 6.35. So this is a 3D truss. It has a ball and socket joint at D. It has two supports at B and one support at A. These are link supports. And it has a force acting down at C. So first thing we want to do is take the free body diagram of the entire body. So since there are two links here, there are going to be two reaction forces. We'll call them By and Bx. It might be kind of hard to visualize all the things I'm drawing here because it's in 3D and I can't draw in 3D very well. But you have the picture here for reference, and I'll be labeling everything here in the X, Y, Z direction, so it'd be too bad. So AX, there's only one reaction force there, and the ball and socket joints have three reactions, so we'll label that. Sorry, I'm having some issues here with this pen here. Let's see. So we have DX, DZ, and DY. Okay, and then we have 400 pounds acting down here. So first thing we want to do is some of the forces on all this, on the entire section here. So if we do some of the forces in the X, we get negative AX minus BX minus DX is equal to 0. Some of the forces in the Y give us dy minus by minus 400 is equal to 0. And some of the forces in the Z will give us dz is equal to 0. So that's one of our reaction forces there. So to get the other ones, we're going to need to do a moment equation. So I chose to do the moment about point D. And this is equal to, so we're going to do it as a vector equation here. So the first one we're looking at is the AX force. And if we look at from point D, it's plus 7 in the k hat direction and plus 10 in the j hat direction. So we're gonna, that's the radius, we're gonna cross that with AX. So AX was in the negative I hat direction. Okay. So that's the first part. Now we need to look at the other parts. So next we'll look at point B here. So this will give us plus B. Point B is 14 k hat, or 14 in the k hat direction away from point D. So we'll just write that cross, and then we can do the sum of both forces that are at B. So we'll say negative bx I hat minus by j hat. Okay, and so that's that force. Now we just need to do the last force here, which is the 400 pounds acting at C. So C is 7 k hat, or 7 away in the Z direction, so that's 7 k hat, and then it's 24 away in the X direction, so that's plus 24 I hat. And then we're going to cross that with cross minus 400 j hat. And this whole thing is equal to the 0 vector. Okay, and so to solve for all of these, you can go through one by one and try to figure out each force individually, or you could do what Professor Castle has been talking about in class and write a matrix equation for this. So that's what I'm going to try to do. I'm going to need a lot of space here to write this all out. So here's our equations. I'll write them right here. Okay, so the moment gave us three equations. There's one in x, y, and z. So with all of those, we also have six unknowns. Okay, dy, dx, dy, dz. Okay, so we're going to have a matrix here, and this matrix is multiplied by these unknowns. And then we're going to have our answer or our solution matrix over here. So the first one we're looking at is sum of the forces in x. It's negative ax minus bx minus dx is 0. So to write that in, oops, so get rid of that. Okay, so to write that in matrix form, we're going to put a negative 1 for the ax column, a negative 1 for the bx column, and a negative 1 for the dx column. And then we said that was equal to 0, so we put a 0 in the solution column, and then fill in zeros for the rest of the terms. We have to do this for every equation here. I'm not going to go through it step by step. If you look back at the equations, you can see where we got these numbers from. Okay. And once we have all of these equations written out, it will just give us a quick and simple solution. If you plug this into MATLAB or even into your calculator, sometimes your calculator can do these problems. Let's see. And this just, it might seem long-winded, but if you have a lot more unknowns, it's going to be really difficult to try to solve all of them simultaneously. You're eventually going to need to start using matrices to solve for these. With this one, I probably could have solved it, but it's just taking up less time if I do it this way. These problems take long enough as it is. So if you plug this into a calculator or some sort of program that can solve it, it will eventually lead to this solution. So AX is equal to 960 pounds, BX is equal to negative 480 pounds, BY is equal to negative 200 pounds, DX is equal to negative 480 pounds, dy is equal to 200 pounds, and dz is 0. So now that we have all that, we need to start going through each joint one by one and doing the solution there. So we'll start with joint B. Also, just a note, because of the symmetry of the truss, we know that AB and AD are going to be equal to each other, as well as BC and CD. So given that, that's going to make our solution a lot easier. So if we look at point B, we're going to have our, let's see, we have our BY force acting down, our BX force acting in the X direction, or the negative X direction. And I have AB, let's see, BD, and BC. Now, of course, this probably doesn't look like much because you just see a dot with a bunch of arrows coming out of it. You really need to look back at your picture to be able to understand what these forces mean and which direction they're acting. So if we look back at the original problem, you can see that AB is acting in the YZ plane, and it's going up and to the right. So we know there's going to be components in the Z direction and the Y direction due to that force. Okay, and so if you can understand that, if you can, wrap your mind around the whole 3D problem thing, it becomes a bit easier, but it can still be confusing. Just keep referring back to the original picture. If you ever get confused, you should be able to tell which direction these forces are acting in. But yes, it can be confusing. So also I wrote over here, we have some force or some lengths here that I just calculated beforehand. So AC turns out to be 26 feet long. AB and AD are the square root of 149, so that's not a very nice number. But BC and CD are each 25, so that'll help us in our calculations. Okay, so here we are, back to the problem. So we do a sum of the forces in the X. This is negative Bx plus 24 over 25 BC is equal to 0. And since we know Bx, we can solve for BC here. BC turns out to be negative 500 pounds. Now with the sum of the forces in the y, we have negative By plus 10 over square root of 149. And I should probably explain where I'm getting these factors from here. So if we look, we're talking about the y direction right now, so this 10 feet is in the y direction. So for AB, since the length of it is square root of 149, the y component of that, we just multiply the force by the direction we're looking for. So in this case, it's the y direction. So its length in the y direction is 10 feet. And then we divide that by the length of the section we're looking at. So the member there is square root of 149. So that's how you get that. So continuing, that was for force AB, and that's equal to 0. So now we can solve for AB since we know By, and it's negative 244.13. That's in pounds. Now we do some of the forces in the Z. So this will give us components in 3 of the members, 2 of which we just solved for. So let's see. We have negative 7 over square root of 149. So that's the other component of AB. AB was made up of 10 in the y direction and 7 in the x direction. So that's where that 7 comes from. And then BE is just in the z direction, so we don't need anything there. And then minus 7 over 25. So the only one we didn't know here was BD, and we can just plug in the other 2 that we just solved for. We end up with BD is 280. And again, like I said, because of the symmetry here, we can just simplify the problem a bit and say that, let's see, it was BC is equal to CD. So that gives us another number, and then we also know that AB is equal to 80. Okay. And I mean, again, if you just look back at the problem, everything is symmetric about the y-x plane, and since there are no forces acting in the z direction here, we know that everything is just going to be symmetric there. Now, it's probably not best to always make that assumption. You should probably solve for them, even though they're going to come out the same anyway. But due to the time limits of this review session, we're just going to skip that for now. And so now we have 5 of the numbers here. So now we just need one more. And I think the easiest one to solve for is going to be at point D. So if we look at point D, it has 400 pounds acting downward. It's going to have a force BD, or sorry, this is point C. This is force BC, force CD, and then force AC. And actually, since the only force we're looking for right now is force AC, that's the only one that's unknown. The only thing we're going to care about is some of the forces in the Z, because other than the 400 forces acting downward, that's the only force acting, or sorry, in the Y, not the Z, that's the only force acting in the Y. So if we do some of the forces in the Y, we end up with negative 400 plus, let's see, so the length of it was 26, and it's 10 in the Y tall, so 10 over 26, and that was force AC is equal to 0. So we can then solve for force AC. I don't have the number right now, let me just calculate that. So it's going to be 400 times 26 over 10. AC turns out to be 1,040 pounds. And so there's our final solution. So there's 1, 2, 3, 4, 5, 6. So we have 6 answers here for 6 members, so we know it's done. Also, you know that several of these forces are going to be in compression. So since BC is in the negative direction, we know that's going to be in compression. AB is also in compression. And then we also said that CD is equal to BC, so that we know that's in compression. And AD is equal to AB, so that's in compression. So the only one that's actually in tension, or there are 2 that are in tension here. It's AC and BD. So in case you needed to solve for that, that's how you would get that. Okay. So the next problem we have here is 6.36. I don't have the words for the problem here or on the screen, so I'm gonna pull that out right now. Take a look. But again, we have a tetrahedral truss here, like in the last problem. Just means it's made up of 6 members, and it's supported with link joints and a ball and socket. So let's see. Okay, so here's what it's in the problem is given to you. So for 6.36, we have P negative 2,184 newtons, and Q is 0. Okay. So let me just try to draw this out here for your body diagram. I hope this works okay. I'm not doing these 3D drawings here. Okay. So that's pretty much what we have. It's not exactly dimensioned like the original thing, but it'll do, I guess. So at point B, we're going to have 3 reaction forces because it's a ball and socket. So let's look good. This is going to be By, and then on, let's see, Bx, and Bz. Z is in this direction. Okay. Okay, at point D, we have 2 reaction forces due to the link joints. So this is dx. Let's see. And then we also have 1 in the y. And then finally at C, we're just going to have 1 in the y direction. So we'll just call it cy. And it's also probably best to try to measure some lengths here to calculate the lengths. So let's see. This might be a bit confusing just because of how the dimensions are given to us. They're given to us about the origin, which is basically directly underneath point A and at the level of all the other points. So just need to think here for a second about what they're actually telling you. So we know that BC is 2.8 meters in the x direction and 2.1 meters in the z direction. So if we try to calculate what that length is, it turns out to be 3.5 meters overall. So let me just write these up here. Okay, so it's 3.5 meters. And actually that's the same for CD, it looks like. So we'll just say that's equal to CD. Because if you look, it's still 2.1 meters in the Z direction, it's just going the other way. We can see that BD is just 4.2 meters long, but let's look at the other dimensions here. So for, let's see, AD, it's going 4.8 meters up and 2.1 meters over. And it's also going 0.8 meters in the x direction. So we need to take all of that into account here. So this isn't going to be as simple. But it's going to be 4.8 squared plus 2.1 squared plus 0.8 squared. and it turns out it's 5.3 meters long. So luckily they gave us some pretty nice numbers to work with here. So we're going to say, let's see, that was AD is 5.3 meters. Okay, and then we're going to look at the same thing for, let's see, for the length of AC. So that's going 4.8 meters in the Y direction and 2 meters in the Z direction. Or sorry, 2 meters in the X direction. So let's look at that. So that turns out to be 5.2 meters long. Okay. And then finally, AB is, let's see, I believe it's the same as AD here. So let me just write this is equal to AB. So that's just going to help us when we're doing our calculations to know these lengths, because we don't have to deal with angles then, we can just deal with ratios of lengths. Okay, so now that we have all that done, let's start trying to do these sum of the forces here. So we have sum of the forces in the X. So this is going to be, oh, sorry, I forgot to draw. We have P acting here, and obviously they gave us Q is 0, so we don't need to draw that. So the only force acting, there are two forces acting in X here. We're going to have Bx minus dx is 0. So we know Bx and dx are equal to each other. We're going to have a sum of the forces in the Y. And this is, let's see, so P is acting in the Y. So let's see, our reaction of By plus Cy, so this is a plus dy minus P is equal to 0. So the sum of the forces in the P is, or in the Y is just going to be P, essentially. Then we can have the sum of the forces in the Z. And this one, we only have one force acting in the Z, which is just BZ, and that's 0. So we already have one of our reaction forces. Now we need a moment equation to get the other one. So let's see. Let me just see if I can resize this, move this out of the way a bit. So now I'm going to do some of the moments here. So whenever you're dealing with 3D problems, you always want to do some of the moments as a vector, and you want to take it about the point where the most reaction forces are. So in this case, because BZ turned out to be 0, you can take it either about point B or point D. But I guess I'll just take it about point B. So first thing, let's see, the simplest force here to look at are for the reactions at D, because they're just 4.2 meters in the negative Z direction, so negative 4.2 K. And then we're going to cross that with the forces at D, the reaction forces at D. So we have negative dx I hat plus y j hat. Okay, so that's our first equation there. So now the next one, we can look at point C. So this is 2.8 meters in the x direction, so that's I hat. And then it's also negative 2.1 meters. Sorry, that's supposed to be 2.1. 2.1 in the z direction, so that's k. This whole thing cross, let's see. It's going to be cross just cy in the j hat direction. Okay, and then our last force is just point P. And so this one, we can actually take it about the origin, since it's acting through the origin, so that'll make it our equation here a little simpler. So it's 0.8 in the I hat, and then it's 2.1, sorry, negative 2.1 in the z direction, so minus 2.1 j hat across py j hat.
And then you need to build so that when I got transfer some of mine to you, skinny.
Okay, and so now we can try to do a matrix thing here again. I didn't really have this prepared, but it seems like that would probably be the simplest way to solve this here. We'll just make a little change here. This is just P in the j hat direction, and it's negative, I guess. Oh no, sorry, I see what they did. They told us P was negative 2,184 in the j hat direction. So it's just P. Here, why don't I write this as a vector then? Oops. Okay, so this is actually a vector here. Having some issues with the marker here. So we're going to say it's cross P, and we know that P is in the negative j direction. So you don't have to do any sign changes here. Okay, so now we can start creating our our matrix equation here. So we're going to have equations from the sum of the forces in each direction and the sum of the moments in each direction. And then we have our reaction forces, which were BZ, BY, BX, DX, DY, and CY. So let me just write that up here. It's C, which was in the Y direction, and then dx and dy. Okay, so that's going to be one big matrix here. And then we're multiplying it by those unknowns. Okay. And then this is going to be equal to our little solution matrix here. So let's go back. We had sum of the forces in the x is equal to bx minus dx, which is equal to 0. So to write that in vector format, we have a 1 in the bx column, a negative 1 in the dx column, and a 0 in the solutions. And then you just fill in zeros for the rest of the terms. Okay, we have to go through doing this for each individual one. So here we have by plus cy plus dy minus p. And since we know p, we can move that over to the other column. So p was negative 2184. But in this case, because of how we wrote it, since we wrote it in the negative direction there, it's just going to be 2184. So we have components from each of the forces here, by, cy, dy, and this is equal to 2184. And we can fill in zeros for the rest of these terms. Some of the forces in the z, we just had bz is equal to 0. So put a 1 here and a 0 here, fill in zeros for the rest of these. Of course, you could make this a matrix of 5 equations and 5 unknowns, but this is just, sort of a more complete way of writing it. So now we want to start looking at solving this, or simplifying this moment equation here. So to start with, I'm going to say this is the moments in the V here. So we have the negative 4.2 k hat cross negative dx and I hat. K cross I is going to be positive j. So we end up with 4.2 dx in the j. And then we're going to have k cross j, which is negative I. But since it's a negative times a positive, it's going to turn out to be positive as well. So plus, plus 4.2 dy I hat. So if you see, it turned out to be a negative times a positive times a negative, essentially, because k cross j was a negative I. So negative I times negative 4.2 times dy turns out to be plus 4.2 dy. I'm running out of room here. Let me just see if I can move some of this stuff over. Maybe make it smaller. Okay. So let's see, moving on. So now we have 2.8 I hat cross cy j hat. And just make this clear, this is a j here. It's not written very well. So I cross j is positive k. So we're going to have 2.8 cy k hat. K cross j is negative I, but since we're multiplying by a negative number, we're still going to end up with a positive here. Plus 2.1 cy I hat. And finally, our last one, our p was in the j hat direction. So let's see. Okay, so we have 0.8 I hat cross a negative 2,184 j hat. So I cross j is positive k. So we need to do this multiplication here. We end up with minus 1747.2. That's I cross j, so it's k. And then finally we have negative 2.1 K cross negative 2,184 J. K cross J is negative, so that's going to give us a negative result overall. So let's see. So that's going to give us minus 4,586.4 I hat. So after all that, this actually turns out to give us three equations if you break it down into the x, y, and z components. So looking at the I direction here, we have this part, and this part, and also this whole thing is equal to the zero vector. So looking at the I hat, we're going to have plus 4.2 dy. Let's go through this step by step. 4.2 dy, 2.1 cy. And then if we move the 4,586.4 over to the other side, that's going to be in our solutions one. Okay, and then we just fill in zeros for the rest of these. If we look at the j direction, we just had one equation here. It's just 4.2 dx. So 4.2 dx is equal to 0. And then finally, we have just one more. We're going to have in the z direction, 2.8 cy is equal to 1,747.2. Okay, and then just fill in zeros for the rest of these. We can now solve for all of the reactions here. So this is going to take a minute just to plug in everything. But basically we have 6 equations, 6 unknowns. So you need to plug in quite a few numbers here. And after everything is said and done, the solution turns out to be Bx is equal to 0, By is equal to 780, Bc is equal to 0, Cy is equal to 624, dx is 0 as well, and dy is equal to 780. So this, if you think about it, this makes sense. The only force acting on it is in the y direction, so it makes sense that the components of the reactions in the x direction are 0. And then it also makes sense that the component in the z direction was 0. So basically you have P, which is split up into three parts and split up into by, cy, and dy. And depending on how far away they are from the force, that determines how large they are. So now we can start looking at it from a joint perspective. So first thing we want to look at here, let's see. Now again, this problem looks to be symmetrical about the origin here. So that's going to make it a lot simpler for us to solve. So if we look back at the original problem, the whole truss is symmetrical about the, the XY plane, which means that CD is equal to BC and AB is equal to AB. And that also played out in the reaction forces. If you look at B versus D, BY was equal to DY, and BX was 0, and obviously there was no reaction force in the X at point D, so it makes sense that BX would also be 0. So everything is just symmetric about that, so that'll make solving it easier. And then it tells us that we should probably look at either point B or point D first. So for our choice here, I guess we'll look at point B. So at point B, the only force we had was in the y direction, so I'm just going to simplify this and write it as just a force in the y direction. We don't need other forces here. So dy, which we said was equal to 780 pounds. And we have BD, we're going to have BC, I'm just going to try something a little different here. Okay, let me try. So we have, okay, so we're going to call that BY. This is, oops. BD, BC, and AB. So this is all acting at point B. So let me just write in the forces here. So we have 780 due to BY. We have AB. We have BD. And BC. BC. A lot of technical difficulty with BC. So it's also good to look back, remember what we had solved for here. BC was 3.5 meters long. And let's see. And the only other force, or the only other one we care about is AB, which was 5.3. So that should be pretty easy to remember. Let's just write that down here, just in case. No. Someone was on.
Someone was on the blackboard.
Yeah.
Really?
But no, they're not.
It was me.
Okay. So, and we're starting on 3D trusses now, so there's problems take forever. I'm only
How
on
long
the
did you
second.
spend to record this?
What?
How long did you spend to record this?
Well, I started at 1. This is all the work.
Wow, that's a lot.
Yeah. Luckily, I was able to copy the pictures from the book. I did not want to try to draw out all these 3D trusses here.
So did you record it or you just save the PDF?
Record what?
You record it as a video, right?
Yeah, it's on Blackboard Library. Yeah, we're recording right now, so if anyone watches up to this point, they're going to hear us talking. It's going to be weird.
Watch us. They're not gonna spend an hour to study one question.
Well, this was 2 questions, so.
Yeah, I mean, like,
This person was just left though. They were in here for like 40 minutes.
40 minutes?
Yeah. They came in at 1 and then watched up until a few minutes ago.
Really?
Yeah.
For me, I never have any students.
I rarely ever. I'm surprised. They probably weren't even paying attention. But yeah. I don't know. But I mean, like a lot of people don't even show up to the class. So
Yeah, like
how are they?
It should be 38 now. There's only 26 people showing class.
Yeah. For mine, it's even worse. There's supposed to be like 60 people in the class, and a lot of times there's less than 40 showing up.
Less than 40? Wow. Who was your teacher?
Professor Castle.
Like, no one came to see me, so what do I supposed to do? Just record all 1 hour video like this bullshit. I don't want to do it.
Yeah. Well, that's what you get paid to do. It's better than just sitting around not doing anything.
Well, I mean it's true, but like he told me like you gotta record video. Like even though I'm teaching someone. I mean like I always teach someone, but like I never record it. But now I need to teach someone on the board and record it. And like he told me I wanna see the video. Like why don't you wanna see the video, man?
I hope he doesn't watch this.
I want to see the video. Like what is the point?
No, I don't know. But do you get a lot of people showing up to the actual review sessions?
It's like 2 or 3.
Do they show up every time?
Just one show up every time, but he's missing for like 2 sessions already. And he don't even show up to class, that guy. Like,
Well, I talked to Hassan, and he said like a lot of people had no one show up to their review sessions last week.
yeah.
Like I don't know, maybe people are just like tired of
Yeah.
reviewing stuff. They just don't want to go to these anymore.
I mean, like, I don't know. He told me, I already start on the problem, I will come, but he didn't show up. I mean, I don't know what's happened now. And people didn't get a good grade, like, they did not really show up.
I mean, I should probably just stop recording.